will be on paint preservation strategies. Charlie Brown has over 35 years of experience in coating industry. He currently works for Greenman Peterson as the Deputy Director of Coatings for the Columbia, Maryland office.
Well, good afternoon, good evening, everyone. As Rod said, I'm the Deputy Director of Coatings. I was a member of the successful bridge preservation practices for steel coatings. And what I like to do is go over some of the things that we did and what we talked about and some of the strategies that various DOTs use to combat corrosion for their bridges in their different environments. Basically, just to give you a quick rundown, corrosion costs a lot of money. I'm not going to go over all these figures. I know we're running short of time, but I just wanted you to understand that we're talking about billions of dollars, lots and lots and lots of money. Our jobs are to try and combat that corrosion, combat that cost, to try and keep those costs down and take our assets, which are our bridges that we've been talking about, and make them last longer. So the scan was basically looking at what kind of funding levels that various DOTs use. Also looking at evaluation practices, surface preparation, coating system decision-making, warranties, coating inspection requirements. So what we did was we sent out a survey to various DOTs asking the questions on all of these different factors. Also talking about inspector qualifications, contractor qualifications, and any other the scan team members that had any recommendations. And we excluded shop coating though. Shop coating was not part of our discussion. So they're the various members that were on the team. They were from various DOTs. At the time I represented Maryland DOT. The person that recommended me to represent the Maryland DOT is actually sitting right here, Mr. Rod Thornton. I actually worked for Maryland State Highway Administration for, 10, 11 years as an area engineer for their corrosion and coatings division. So when this came up, Rod asked me if I would do it, and I was more than happy to. We also had some other workshop participants and other DOT owners. This is just a picture of the various people that participated in the workshop. We got a good cross-section from East Coast, West Coast, and some from the Midwest. Agency funding levels, all 13 agencies that we talked with that provided a presentation have preventive maintenance programs in place. 6 agencies have dedicated steel bridge preservation programs. Most organized and effective implementers seem to be based on inventory size. So the larger your inventory, the more organized you're going to be. I know in Maryland we have somewhere in the neighborhood of 1,900 bridges, or somewhere in that neighborhood.
What, you mean steel? Or
yeah, steel.
Bridges? Yeah, steel.
Steel, sorry. We have a lot of bridges that are concrete as well. In Maryland we had a mandate that we don't want to have any more repairs to beam ends. That was one of the things that we talked about. We also talked about that in the Federal Highway Preservation Guide, paint is listed as a preventive maintenance action, along with debris cleaning, bridge washing, etc. The idea here is that a lot of people think about paint, they don't think about it fully in regards to planning and having a program in place. Whether you fund it with $2 million or $10 million, whatever the price you can get or the money that you can get, have some type of paint preservation program, a coatings program. Because of the cost and repairability, paint's considered a bridge element. A lot of the DOTs, they perform assessments before making maintenance painting decisions by following the National Bridge Inspection Program, the data. They use their 2-year frequency biannual in-service bridge and safety inspections. We do the same thing in Delaware, Maryland, and a couple other states that I work in. The big thing though is having a program. I'm going to probably say that over and over again because it's important to have something. Just having a program where you say, well, we got to paint that bridge, and then putting out a program just to paint that bridge is fine, but you need to look at your total assets, all of your bridges, all of them that are in your inventory, to decide, let's set up a program. If you start out small, that's fine. But then you're going to understand that when you start getting into bigger projects and understanding that we got a bigger problem, at least you have the starting blocks in place that you can ramp up to go if you get more funding. Under selecting coating candidates, there's a triage method that you can use in the elemental level bridge inspection data. You can also conduct special coatings inspections and you can prioritize. That's what we do. That's what we've done a lot in Maryland. We use a special coatings inspection, and we use that coatings inspection with the elemental data to prioritize which bridges we're going to have painted and what we're going to be painting down the road in 3, 4, 5, and 10 years. You can leverage the agency-defined elements, the 515 element. You can also look at different conditions. Like, for instance, Oregon, they looked at the condition of the entire superstructure coating system, not just specifics, like beam ends and joints. Virginia is one of the conditions of the beam ends is that they decided to start, as Will pointed out earlier today, they started with putting the joints behind the back wall of the bearings so that your bearings didn't get corroded with all the salts and all the junk that comes down through the joint when the joint fails, because we all know that a good joint installed is going to last probably 3 to 5 years, and after that it's probably going to start to fail. When we talk about overcoating, there was not a lot of DOT agencies that were looking at overcoating. Overcoating is, in some respects, paying for the same real estate twice. If you have minor areas that you wanted to overcoat, that's fine. But when you start dealing with overcoating with lead paint, which lead is still a fairly large issue, you have environmental and safety considerations, just like you would do if whether you were doing an overcoat or if you're doing a complete clean and repaint. And then we talked about California has their own in-house painting crews. Their whole job was to extend the life of the lead paint that they currently had on their structures. That's the reason, one of the reasons they did a lot of overcoating was to extend that lead coating, because of course we all know that lead coating is the best corrosion inhibiting coating out there. When we talked about surface preparation, all the agencies basically specified SP10, which is a total removal, which is an SSPC near white. Depending on your surface preparation, it's varied depending on whether you're doing localized, you're doing spot cleaning or overcoating. Whatever you're going to be doing, you're going to be probably using SSPC's Guide 6 for containment. The SSPC Guide 6 actually just got reauthorized again in December 2021, just to let you know. But here you can see that you have some very complex structures that you need containment for, and then you have not so complex. You're using a power tool with a vacuum-assisted HEPA vacuum cleaner. There's different ways that you can do the containment. When we talk about weathering steel, most surface preparation for weathering steel is near white, the SP10. The location of corrosion issues, this is actually a picture I took on a bridge where you can see that the bottom of the flange, or the top of the bottom of the flange, you see section loss starting to occur working up the web, as well as on the bottom of the top of the flange. The issue with weathering steel is that you have these localized areas. Specifically, you have drains. I was doing an inspection on a lot of bridges, and we have these drains that are coming down, the scupper drains coming down, and they leak. I don't know how many bridges that you've actually taken a look at, but I mean, almost every bridge I go to see, these scupper drains, unless they're brand new, most of them are all leaking. And they're causing issues, especially with weathering steel, which people think, weathering steel, we don't have to do anything about weathering steel. It's weathering, it'll handle the weather, it'll handle the water, but it doesn't. You got to look at corrosion on steel in the downslope vicinity of any deck drains. You also look at corrosion on the fascias, primarily the lower beam flange areas, as you can see here. And corrosion near roadway joints. Note that most weathering steel girders near roadway joints are zone painted, and they're zone painted for a reason. A lot of weathering steel bridges, you'll notice, are zone painted at the joints, and they're also painted on the fascias. Isolator corrosion due to aggressive exposure to roadway runoff splash due to the proximity of the ground. We've run into a situation where we're noticing in weathering steel where we're having an issue with bridges about 20 feet, 25 feet, or a little bit lower over road. We're getting a lot of corrosion on the bottom flanges and a lot of section loss. Some of that has to do with the new treatment products that are being used. Some of it has to do with they've just never been cleaned. Used to have a bridge washing program back in the days, but most of those bridge washing programs have gone away based on having to contain and collect all the water because of new environmental regulations. So the idea here is looking at weathering steel. It's not a cure-all for issues. You have to look at it and pay particular attention to where you're going to put it. We took over a bridge in Maryland from the city. It was an arch bridge that was 10 years old. And the arch bridge went over a reservoir. It was actually, that bridge as you see right there on the right. That bridge was only 10 years old when we went out there. We had to clean and paint the whole bridge. Mainly we cleaned and painted it because from the roadway down, we had section loss occurring where we had to do steel repairs. Yeah, after 10 years. So in that situation, because of the reservoir that was underneath of it and the moisture, this weathering steel never got to dry out. So like I said, you have to make sure that you use the weathering steel in the correct locations. When we were talking about it in the domestic scan, we were talking about the various coating options and the decision making. Most agencies use the 3-coat system when they're doing a complete clean and paint. The 3-coat zinc-rich epoxy urethane is the one that most everyone uses. Most expectations are 15 to 30 years. If it's got good inspection with a good spec and a decent contractor, you can probably get a 20 to 30 year life expectancy out of that coating. There was general satisfaction with most of the domestic scan members with the 3-coat system. They were also looking at other coating systems. We were looking at some ultra weatherable coating systems like siloxanes, polyura, fluoropolymers, but we really didn't have any data to justify their use, but because a lot of them are very, very expensive. Metallizing is another one that people are starting to look to. The idea behind metallizing is that you can apply a metallized coating on top of the steel and then coat that metallizing, which could give you a conceivable 50-year lifetime coating for that structure. It's still out there. People are using it. I'm not currently sold on it yet, but I know it's out there. The other thing is warranties. Maryland and Michigan have 2-year warranties. Oregon uses a 3-year warranty with 90% of the coating line items. The Golden Gate Bridge uses a 5-year warranty, which is contracted for labor and materials. Virginia uses a 1-year, and Ohio has a 3-year warranty they've used in the past, but right now they don't have one that they're using currently. So a lot of people wanted to talk about warranties. I know that one of the ASHTO committees I'm on for paint preservation is talking about looking into putting together a program for setting up what kind of warranties DOT should use. Right now we're looking at the sweet spot about 2 years, which is what Michigan and Maryland uses. It's not so long that you're going to forget about it. It's also, if you go there in 2 years and there's a problem, or if there's going to be a problem, you'll see it within 2 years. But the problem is defining the failure. That's the tricky aspect of it. When we talk about coatings inspection, that's one of the big things that I said earlier. 3 things you need is a good contractor, good specification, and good inspection. Various DOTs do in-house inspections. Sometimes they hire consultant inspectors. It all depends on the DOT and how they have it set up. Some of them have blended inspectors. We do some work in Kentucky where we have Kentucky inspectors as well as consultant inspectors. The big thing is making sure you get the right consultant certifications for the inspector that's going to be doing the work. At a minimum, you want to see at least a NACE level 1 or a SSPC BCI. Some require a NACE level 2, depending on the work that's being done, and a BCI level 2. And then the minimum in-house certification varied between DOTs. During our coating inspection talks we had based on the domestic scan and the DOT agencies that were there, we talked about hold points and to maximize these hold points so that we, either the in-house consultant, or excuse me, the in-house inspector or the consultant could do their inspections to ensure that every step of the project was being followed according to the specification. Another one was that they talked about it and we all agreed that 100% quality assurance inspection was good if you could afford it and you can put somebody out there. Verification leads to quality, and that's what we're really looking for here is quality. We're paying millions of dollars, depending on how big a bridge is, or hundreds of thousands of dollars to paint this bridge. Don't we want to make sure that it works and it lasts for 20 to 30 years? With QA inspection, you get a much better verification and quality in the end product. And then striping. The big thing about striping is there are various different ideas behind stripe coating. The big thing about stripe coating is make sure it's tinted and ensure that if it's in the spec that the contractor follows the striping requirements. And if you don't have striping in your contract, I'd recommend putting in there, especially for your edges, your crevices, Those are all areas where you're going to get real thin coatings on them. As the coating tends to dry, it tends to shrink a little bit, especially on the edges, so you want to definitely stripe coat. So when we talked about asbestos inspector qualifications, all agencies require training before assigned a bridge project, and that's real important. You don't want to hire an ACE certified level 1 inspector or a BCI level 1 inspector who just got a certification yesterday. You want to make sure that they have some kind of on-the-job training, they've had some kind of experience. Usually 2 to 3 years is what we look for. And then you want to have some type of in-house instructor-led training if you can. At GPI, I do a lot of the training for our guys, so it's real important that you have some kind of in-house training. A lot of the agencies used contractor qualifications. They used SSPC's QP1 and or QP2. It's a qualification. It's not the thing that's going to fix everything. You hire a contractor that's QP1 or QP2 and then that's it. That's not the case. All QP1 and QP2 qualifications dictate is that the contractor has the means, the methods, the equipment, the knowledge to do the work properly. It doesn't mean the contractor is going to follow all the rules. Believe me, I was a contractor for 14 years before I came to work for GPI. I've been with GPI the past 14. Now I was operations manager for a painting contractor, so take my word for it. And then our other findings we talked about eliminating deck joints. That was what Virginia brought to the table. As Will had said earlier, and I mentioned earlier, that is something that even Maryland is starting to do. It's getting rid of the deck joints, trying to get the deck joints put behind the back wall. That being done, it eliminates all that corrosion. And I've seen some bridges that we've had built with the joints on the back wall, or behind the back wall, and they're 10, 11 years old, and they look like they were painted, a month ago. So, I mean, it really does make a difference. The other findings we did was one of the agencies we talked with, which was NASA, uses a one-coat inorganic zinc. This panel you see a picture of was a picture that I took. We were at NASA, and NASA has these panels all laid out right there on the beach so that they can get data for various paint manufacturers that put out the panels. Most of the agencies preferred inorganic zinc to organic zinc. However, field application of inorganic zinc is difficult. It's not impossible, but it is very difficult. Well, some of the recommendations from the SCAN team were dedicate bridge paint funds. Like I said earlier, it's very important. Dedicate some funds. Even if you start small, dedicate some funds. Set up evaluation practices prior to going out there and doing recoating work on bridges. And use your inspection elements from your biannual bridge safety inspections. And then on your surface preparation, some of the Oregon, for instance, use ultra-high pressure washing to remove pack rust. We've also looked at using crevice sealer to inhibit corrosion. That's been done in various states. And then the coating option decision making. We've been talking about hot dip galvanizing, metallizing, duplex systems over those products. We've also talked about ultra-weathable coatings and untopped inorganic zinc. I've seen quite a few bridges and quite a few steel structures that have inorganic zinc, and that's it, nothing else. It goes on, they put it on 5 to 6 mils, and that's it. They don't put anything else on top. Some of the problems with that is that you don't have a aesthetic pleasing look from the bridge. It's kind of gray and dull and ugly. So that's just something. But if you have a bridge where you don't have to worry about aesthetics, that's something you can think about. The other thing is we talked about, and that's one of the things we're still working on, is putting together performance-based warranties and talking about how long the length of the warranty and what kind of specification language we're going to be using. And then we talked about specifications for coating systems. Specify SSPC SP10 near white blast cleaning for any total removal or replacement. Also, when we talk about beam ends, specifically weathering steel, use SSPC SP10 near white when you're going to be doing your beam ends for your weathering steel. Incorporate hole point inspections for any of the work that you're going to be doing. And then if you can, hire full-time inspection/inspectors and definitely put stripe coating into your contracts. We talked about quality control inspection. Specify NACE level 1 or BCI level 1. Also, if you can, in your contract, specify QP1 and QP2 for the contractors. So at least you have some idea that the contractor that is bidding on this work has an idea of how the work is to be done. And then the agency commitment to support future preservation of coatings. Track coating information on bridges. That's one of the things that when I came to work for the state highways is we didn't have a tracking mechanism. And I helped set that up along with the engineers that I had worked with. And it made it a lot easier for us to determine what bridges we needed to look at and what bridges needed to be painted down the road. We're doing the same thing in Delaware, we're doing the same thing in Virginia. And then eliminate the joints whenever possible. And then when you talk about waste disposal, specify it as hazardous waste, unless the contractor can prove with third-party testing that it's not hazardous. The Scan-T report's located on the AASHTO Bridge Preservation website, and it's under the Scan 1503 Successful Preservation Practices for Steel Bridge Coatings. I try to get it done quickly. Any questions? I'm going to be here all day today, and well, I'm going to be here all day tomorrow. Yes, sir. I can't hear you. No. When you start grinding, what you're going to do is you're going to start imparting that pad, the grit from the pad into that steel. And what you're going to do is you're going to get some high and low spots in it. And if you don't put enough coating on it, you're going to get bleed through rusting on those grinded areas. Basically, when you're talking about high areas, as you mean is in coating high areas, or are you talking about? Oh, sharp edges. Oh, I'm sorry. Okay. On the sharp edges, just round them. Sorry. I thought you were talking about high as in coating thickness was too high. Okay. Amen. Anybody else? Well, thank you. If you got any questions, like I said, I'll be here all day tomorrow. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.